Good day, everyone. Welcome in physical science. Before we start, we'll be having a pre-test. So choose the letter of the best answer in each item and write it on a separate sheet of paper. Number one, liquids can form spherical elastic film to minimize surface area. What intermolecular force is responsible for the formation of this film in water? A. H bonding. B. Ion-induced dipole. C. Dipole-induced dipole. D. London dispersion force. The answer is letter A. 2. The amount of energy required to stretch or increase the surface of a liquid by a unit area. A. Specific heat. B. Surface tension. C. Vapor pressure. D. Heat of vaporization. So the answer is letter B. 3. The ability of water molecules to move against gravity. A. Viscosity. B. Temperature. C. Surface tension. D. Capillary action. So the answer is letter D. 4. Substances like heavy syrup and molasses flow slowly than water. The ability of these substances to resist water is known as A. Viscosity. B. Pressure. C. Surface tension. D. Capillary action. So the answer is letter A. 5. The pressure exerted by vapor due to evaporation of a liquid or a solid in a closed container. A. Boiling point. B. Capillary action. C. Surface tension. D. Vapor pressure. So the answer is letter D. 6. What is the true about liquids with strong intermolecular forces? A. Vapor pressure is low. B. Vapor pressure is high. C. Viscosity tends to be low. D. Viscosity is immeasurable. The answer is letter A. 7. Which of the following occurs when the vapor pressure of a liquid becomes equal to the atmospheric pressure? A. Boiling. B. Melting. C. Freezing. D. Condensing. The answer is letter A. 8. Using the chart on the vapor pressure of the four substances, which among them has the lowest boiling point? This is the substance, and this is the vapor pressure in 25 degrees ATM. So we have diethyl ether, bromine, so ethyl alcohol, and water, and with their vapor pressure in 25 degrees atmosphere. A. Water. B. Bromine. C. Ethyl alcohol. D. Diethyl ether. The answer is letter D. 9. Based on the Lewis electron dot symbol below, which has a lower boiling point, and what accounts for the difference based on the intermolecular forces present in each species. So this is the structural formula of diethyl ether. This is for ethyl alcohol. A. Ethyl alcohol has a lower boiling point due to the dispersion forces present among the molecules. B. Ethyl alcohol has a higher boiling point because of the predominant hydrogen bonding present among the molecules. C. Diethyl ether has a lower boiling point due to dipole-dipole interaction. D. Diethyl ether has a higher boiling point because it is capable of forming hydrogen bond. The answer for number 9 is letter B. 10. The atmospheric pressure on top of the mountain is lower than at sea level. And as consequences, what will happen to the cooking time of an egg on top of the mountain? A. The egg will cook faster since the boiling temperature will be lower. B. The egg will cook at a shorter time since the boiling temperature will be higher. C. The egg will cook at a longer time due to a lower boiling temperature. D. The egg will cook at a shorter time due to a higher boiling temperature. So the answer is letter C. 11. Sodium chloride is completely soluble in water. What is responsible for its solubility in water? A. London dispersion forces in sodium chloride predominate, leading to strong dipole interactions with water. B. The presence of charged ends in the sodium chloride enables dipole-dipole interaction with water. C. The ions in the sodium chloride participate in an ion-induced dipole attractions with water. The sodium and chlorine ions are favorable sites for hydrogen to form. So the answer is letter B. 12. Xenon has a higher atomic mass than neon. Xenon has 131.3 atomic mass unit, while neon has 20.2 atomic mass unit. The boiling points are 166.1 Kelvin and 27.3 Kelvin respectively. How do intermolecular forces account for the difference? A dipole-dipole interaction is greater in xenon than neon, so more energy is needed to break the bonds. B. Hydrogen bonding is greater for substances with higher atomic mass, so greater energy is needed to change the xenon to vapor. C. Atomic weight increases the chance of lesser dispersion forces, so greater energy is needed to separate xenon atoms to change to vapor. D. London dispersion force is greater in the substances with heavier atomic mass, so greater energy is needed to separate the atoms of xenon than neon. So the answer is letter D. 13. Which is more viscous between glycerol and water based on their leads and intermolecular forces? So this is the structural formula of glycerol and this is for water. A, glycerol because it has more OH groups that form non-dispersion forces among the molecules. B, glycerol because it has more OH groups than form hydrogen bonding among the molecules. C, glycerol because it has less OH groups that form London dispersion forces among the molecules. D. Glycerol because it has less OH groups that form hydrogen bonding forces among the molecules. So the answer is letter B. 14. When does boiling occur? A. When the vapor pressure of a liquid is equal to atmospheric pressure. B. When evaporation occurs at the same time with condensation. C. When the rate of vaporization is equal to the rate of condensation. D. When the amount of vapor inside the container is equal to the amount of the liquid. So the answer is letter C. 15. Which is true of vapor pressure? A. It is affected by the surface area of a liquid or solid. B. Vapor pressure is higher when temperature of the molecule is low. C. Molecules with a high molar heat of vaporization has low vapor pressure. D. When vapor pressure is lower than atmospheric pressure, boiling occurs. So the answer is letter C. Now, our topic for today is effects of intermolecular forces on properties of substance. Our objectives are, so one, identify the intermolecular forces present in each of the given substance. Two, compare the strengths of intermolecular forces in pairs of substance. Three, predict which among the given substance will exhibit highly boiling, melting, and freezing points, viscosity, surface tension, and solubilities. Four, explain the effects of intermolecular forces on the properties of substance. The properties of matter can be seen from either the submicroscopic or macroscopic level. The submicroscopic level includes the atoms, molecules, and ions, which we cannot see. The macroscopic level shows how the bulk properties are exhibited by matter. These properties include surface tension, viscosity, boiling, melting, and freezing points, and solubility. Intermolecular forces play a very important role to determine how substances behave at the microscopic level. In this lesson, you will learn how the different forces of attraction bring about the bulk properties exhibited by substances. This lesson will help you understand why a certain substance behaves differently from others. Now, before we continue our lessons, we'll be having a simple activity that can help you recall what you understood about the types of intermolecular forces present in each substance. Now, for the direction, number one, use a clean sheet of paper to answer this part. Two, copy the table and fill it up with the correct information. Three, show the directions of the dipole moment for each molecule. So we'll be having intermolecular forces present in substance. We have substance here, the LEDs, the shape, the polarity, and the intermolecular forces. All right. Now for the answer of the set activity, so we'll have substance. Now, number one, we have methyl alcohol. So this is the Lewis electron dot symbol. The shape is tetrahedral and bent. Polarity is polar. The integral forces present are hydrogen bonding, London dispersion forces, dipole-dipole interaction. For number two, we have ozone. The lead is here. So the shape is bent, the polarity, and the forces, London dispersion forces, dipole-dipole interaction. So now for number three, we have methylamine. So this is the leads, and the shape is tetrahedral and bent. So we have polar and hydrogen bonding, London dispersion forces, dipole interaction. For number four, we have the iodine. So this is the lead. So we have shape, the linear, polarity is non-polar, the intermolecular is London dispersion forces. And for number five, we have here the hydrogen fluoride. So we have the leads, and the shape is linear, polarity is polar, and chemical forces is hydrogen bonding, long dispersion forces, dipole-dipole interaction. The properties of substances viewed on the microscopic level can be explained by the types of intermolecular forces present between and among substances. These bulk properties can be predicted through an analysis of the interplay of intermolecular forces in each substance. The chart below tells us of the relative strength of intermolecular forces. This can be used as a reference when the IMF is being related to the properties of substance. So this is the relative strength of intermolecular forces from strongest to weakest. So the strongest is the ion dipole, followed by the hydrogen bonding, the dipole dipole, and dipole induced dipole, and the weakest is the London dispersion forces. Properties of substance affected by intermolecular forces. Number one is the surface tension. So this is the amount of energy required to stretch the surface area of liquids. For example, is 1 square centimeter. Liquids with high intermolecular forces tends to have high surface tension. When water is dropped on a waxy surface, so it tends to form a round bed to minimize the surface area that it occupies. An example of surface tension is capillary action. It is the ability of liquid molecules to move against gravity. The forces bringing about capillary actions are cohesion. So this is the intermolecular attraction between like molecules. And of course, we have adhesion, and this is an attraction between unlike molecules. Water molecules exhibit cohesion, while the attraction between water and the sides of the glass tube is adhesion. If adhesion is stronger than cohesion, the liquid is pulled upward. The cohesion is greater than adhesion, there is dispersion or lowering, resulting to a lower height of the liquid in the capillary tube. This is the capillary action in water and in mercury. So we have the adhesion is greater than the cohesion, and adhesion is less than cohesion. So the stronger the intermolecular force possessed by molecules, the higher is the surface tension of the substance. Viscosity. So this is a measure of liquid's resistance to flow. So the greater the viscosity of a liquid, the more slowly it flows. The viscosity of a substance decreases with the high temperatures. So thus, zero flows faster when hot. The strength of intermolecular forces affects the ease with which substances flow. Liquids that have high intermolecular forces are highly viscous. Also, the presence of strong hydrogen bonds in some liquids makes the substance high viscous. So the leads of glycerol below shows three OH group that can participate in hydrogen bonding, whereas water has only one OH group to form hydrogen bonding. So glycerol is more viscous than water. So we have here the three OH group, meaning alcohol, attached to this atom. And we have here only one OH group been attached to, okay, form hydrogen bonding for water. Boiling point and melting point. So boiling point depends on the equilibrium vapor pressure exerted by the liquid or solid above the liquid or the solid. This means that the rate of vaporization is equal to the rate of condensations of substance in a closed container. Vapor pressure is also varies with temperature. The graph below shows the effect of temperature, okay, on vapor pressure of water. So at 100 degrees Celsius, so the vapor pressure is equal to the atmospheric pressure, okay, of 1 atmosphere. So here is 1 atmosphere. So 100 degrees is equal to 1 atmosphere for vapor pressure. Boiling occurs at this point. So when the vapor pressure of water is equal to the pressure of the atmosphere, there are substances that boil at a lower temperature and some at a higher temperature. These temperatures depend on the vapor pressure exerted by liquids or solids. So vapor pressure, on the other hand, depends on the intermolecular forces present in the substance. When the intermolecular forces are strong, then the vapor pressure is low. As a consequence, boiling will occur at a higher temperature because more energy is needed to break the intermolecular bonds of the substance to change into vapor. Water, for example, exhibits hydrogen bonds, such that vaporization needs more energy to change the liquid to vapor. London dispersion forces predominate in methane. These are the weakest force of attraction among molecules. It needs a little energy to break the bonds such that the methane changes to vapor easily. As a consequence, more vapor are released in which vapor pressure will eventually equal to the atmospheric pressure. Boiling then will occur. So this explains why the water has a higher boiling point than methane. This condition is also true for melting point. So the ease with which bond breaks affects the melting points of substances. The greater intermolecular forces there are among molecules, the higher is the melting point. The strength of dispersion forces also depends on the size of the molecules of the substance of the number of electrons in the molecules of the substance. So the ease with which the electron distribution is distorted explains the amount of dispersion forces that a substance exhibits. The distortions of the electron distribution is known as polarizability. The greater the polarizability of the electron distribution, the greater are the dispersion forces. With the dispersion forces are high, so the boiling point and the melting points are also high. Right, we have bromine and fluorine are both diatomic gases. They have also both nonpolar, but bromine is a bigger molecule than fluorine. So the polarizability of bromine is greater than fluorine, so it has greater dispersion force. This explains why bromine gas has a higher boiling point than fluorine gas. So greater amount of energy is needed to overcome the big dispersion forces in bromine gas than in fluorine gas. Next one is solubility. So solubility is the ability of a substance, whether solid, liquid, or gas, so to dissolve in a given substance. The amount of any substance dissolves in a solvent. So the substance that dissolves another substance. So depends on the types of interactions among molecules, pressure, and temperature. The rule like dissolves like applies to solubility. So this means that the kind of substance being dissolved should exhibit the same properties or should be compatible for them to form solutions. The polarity of molecules is an important factor for substances to dissolve in a certain molecules. The highly polar molecules will be dissolved substances that have dipoles. The negatively charged particles will be attracted to the positively charged particles of the involved substance. This attraction will subsist in the solution. Water is often considered as universal solvent because of its ability to dissolve almost numerous substances. Remember that water is incapable of dissolving all solutes, especially nonpolar substances. But water has the ability to form hydrogen bonds with polar substance and nonpolar substances above the nature. Nonpolar substances, on the other hand, will also dissolve nonpolar substances. Intermolecular forces, such as dispersion forces, will prevail to maintain the dissolutions of substances. So, to predict the behavior of substances, several considerations should be taken. So, first, the polarity of substance should be determined together with the predominant and intermolecular forces present in substance. For example, sodium chloride and methane. So sodium chloride is a dipole, while methane is nonpolar. So dipole-dipole interaction is predominant in the sodium chloride, while dispersion force is present among methane molecules. Since dipole-dipole forces are stronger than dispersion forces, sodium chloride will have a higher boiling point or and melting points. It is also highly soluble in water due to ion-dipole interactions that will prevail. Methane is not soluble in water because there are no poles that will participate in the dissolution process with water. Between carbon tetrachloride and trichloromethane, trichloromethane has higher boiling point and melting points. than carbon tetrachloride. It is also slightly soluble in water. So trichloromethane is a polar molecule, while carbon tetrachloride is a non-molecule. The dipole-dipole interaction, okay, in trichloromethane is stronger than the dispersion forces in carbon tetrachloride. Again, the boiling points and melting points are higher in trichloromethane than in carbon tetrachloride. Hence, since trichloromethane is polar, then it is soluble in water. Ammonia and methyl fluoride are both polar, but the ability of ammonia to form hydrogen bonds qualifies it for higher boiling and melting points than methyl fluoride. At the same time, hydrogen bonding also enables ammonia to be more soluble in water than methyl fluoride. Phosphorus pentafluoride and phosphorus pentabromide have the same molecular shape and polarity. What matters here is the size of the molecule when comparing the properties of the substance. Bromine contains more electrons than chlorine. This makes that uh, phosphorus pentabromide, so it has the higher boiling and melting points than phosphorus pentachloride. Since these two substances are both nonpolar, then they are not soluble in water. Pentane and isopentane both contain the same number of carbon and hydrogen atoms in the formula. However, their molecular structures are different. Below are the leads of the two substances. So we have pentane has extended structure while isopentane has a compact structure. So extended structures provide more opportunities for interactions than compact structures. Extended molecules have stronger intermolecular forces than compact structures. As such, the boiling point of the pentane is higher than that of isopentane. It is also true of their melting points. So both molecules are nonpolar. So they are not soluble in water. So this is the structural formula of pentane and isopentane. The nature of these intermolecular forces present in molecules in a good uh, gauge to predict properties of substance. Now for our activity, so here, identify the principal type of solute solvent, interaction responsibilities for forming the following solutions. So we have for letter A, B, C, and D. And we have here for number 2 and of course for number 3. Another activity, factors affecting the strength of intermolecular forces among molecules. So refer the pairs of substances to answer the questions that follow. So for letter A, sodium chloride and methane. B, carbon tetrachloride and dichloromethane or chloroform. Next, ammonia and methyl fluoride. And we have for letter D, phosphorus and pentachloride and phosphorus pentabromide. Letter E, pentane and isopentane and fluorine and bromine. And identified intermolecular forces present in substance in each pair. So which of the forces predominates in each substance? Choose which substance will have greater intermolecular forces of attraction. Predict which substance in each pair will have higher boiling and melting points. For another, refer to the chart below and physical properties of matter. So answer the questions and relate the intermolecular forces present among the species to explain the different properties exhibited by the substances. So we have here melting points and boiling points is substance, the molar mass in grams per mole, and melting point in Kelvin and boiling point in Kelvin. And you are going to answer A, which substance has highest melting point and boiling points. B, what intermolecular forces of interactions are present in each of the substance. C, how do the intermolecular forces present relate to the size of substance. D, how do the strength of intermolecular forces present in each species compare to each other. E, how does the strength of intermolecular forces relate to the boiling and melting points of the substance? And what are the properties of matter influenced by intermolecular forces? And rank the intermolecular forces in order of increasing strength? And what steps of considerations do we take to determine the effects of intermolecular forces on the properties of matter? So we have knowledge concept is not enough for our learning experience to be meaningful. So we should also understand how the concepts we learned on intermolecular forces can be applied to real life situations to get the most out of what we've learned. So let us look at a simple situation that will help us realize the advantage of fully understanding intermolecular forces or concepts. You are asked by your mother to cook pork nilaga, so you have only an ordinary kettle to use for cooking. She even reminds you to save energy because we are in a state of pandemic due to COVID-19. Saving resources nowadays is a must because we are not sure of the world's economy. As a student of physical science and with your knowledge of properties of matter in relation to intermolecular forces, how are you going to perform your task in such a way that the energy is not wasted? Now for the assessment, so choose the layer of the best answer. Write the chosen layer on a separate sheet of paper. So number one, the properties of matter seen at the microscopic level influenced by intermolecular forces. A, bulk, B, ionic, C, covalent, and D, individual. Two, which intermolecular forces depend on the polarizability of molecules? A, dipole, ion dipole, B, dipole, dipole, C, hydrogen bonding, D, London dispersion forces. 3. Cohesive forces bring out capillary action. These forces are A. Pulling molecules towards gravity, B. Interactions among polar molecules, C. Interactions among different molecules, D. Drawing together of the same kind of molecules. 4. When adhesion is stronger than cohesion, the liquid is pulled A. Upward and results to concave meniscus, B. Downward and results to convex meniscus, C. Upward and becomes higher than the surrounding liquid, D downward and becomes higher than the surrounding liquid. We have 5. What is true about viscosity of substance? A. Viscosity of substance increases as the temperature increases. So B. The least viscous substance flow the slowest among the substances. C. Molecules that form hydrogen bonds have higher viscosities than those with London dispersion forces. D. Substance with London dispersion forces exhibit greater viscosity than those with ion dipole interaction. 6. When intermolecular forces are high, the boiling point is expected to be A low, B high, C dependent on the kind of atoms, or D dependent on the number of atoms. 7. Water is a polar molecule that is capable of forming hydrogen bonds. What is expected of its vapor pressure? A. It will be low since weak intermolecular forces are present. B. The polar ends will hinder the break of bonds, thus less water vapor is produced. C. Vapor pressure will be high since great amount of energy is needed to break the hydrogen bond. D. Vapor pressure will be low since it's hard to break the hydrogen bond among the molecules and escape as vapor. 8. Which intermolecular forces among the following allows for easy escape of molecule to the vapor phase? A. Hydrogen bonding, B. Ion dipole forces, C. Dipole-dipole interaction, D. London dispersion forces. 9. The vapor pressure on top of the mountain is low. So what will happen to the cooking time of an egg up there? A. The cooking time will be longer since the temperature of the water is higher. B. The cooking time will be shorter since the temperature of the water is higher. C. The cooking time will be longer since the temperature of the water is lower. D. The cooking time will be shorter since the temperature of the water is lower. 10. Naturally, methane will not dissolve in water because A. Greater molar mass of water than methane. B. The same intermolecular forces they possess. C. Difference in the kinds of atoms and their structure. D. Difference in intermolecular forces between the two substances. 11. Which among the following substances has lower viscosity than methyl alcohol? So here, so we have water, ethyl glycol, acetone, and ethyl alcohol. And of course, this is the uh, structural formula of methyl alcohol. 12. Arrange the following substance and increasing boiling points. So we have here for the first one is carbon dioxide, water, oxygen gas, and we have here C6H12O6. For number 13 to 15, so identify the predominant molecular forces present between each pair of molecule. Number 13 is water and acetic acid, and 14, carbon dioxide and methane, and 15, potassium iodide and water. Now the answer is for number 1A, 2D, 3D, 4C, 5C, 6B, 7D, 8D, 9C, 10D, 11C, 12B, 13 hydrogen bonding, 14 London dispersion forces, 15 ion dipole. Now for your additional activities, this part will test whether you fully understand the influence of intermolecular forces between and among species to the bulk properties of substances. You can answer this by recalling the strategies discussed earlier in this lesson. Remember also that the predominant thermonuclear forces are the determinants of what the bulk properties of substances will be. So we're going to explain the differences in the boiling point in terms of intermolecular forces. So we have three activities here. Thank you everyone and have a good day. See you next meeting.